For section 8.1, for factors and greatest common factors, you have to write the prime factorization of each number. What that means, anytime you see the word factor, that means you have to multiply something. So prime factorization means you're going to have to multiply prime numbers together. So, easiest way to figure out what the prime numbers are is to do a factor tree. So you say, what can I multiply to get 54? Well, you can do 6 times 9. Somebody else may have said you could do 2 times 27. It doesn't matter how you start. Then 6 is 2 times 3. 9 is 3 times 3. So 54 is equal to 2 times 3 times 3 times 3. Or you can do 2 times 3 cubed. I'd accept it either way. Tomorrow when you're taking your test and you get your answer for that, type your answer back in the calculator and make sure you get 54. That way you can know absolutely that you're right. The only reason that it wouldn't work out is if maybe you didn't have all prime numbers, but I know 2 and 3 are prime numbers. Okay, then 42. You can do 6 times 7. 7's prime, and 2 times 3 is 6. So I know 42 is equal to 2 times 3 times 7. And once again, type it in your calculator and make sure you get back to 42. 50, I can do, anytime it ends in a 0, you can do 10. So I do 10 times 5. 5's prime, then I can do 2 times 5. So I would say the prime factorization of 50. 50 is equal to 2 times 5, or you could write 5 squared. And then go back in, type it in your calculator, see if it works. For 120, it also ends in a 0, so I know I can do 10 times 12. 10 is 2 times 5, which are both prime. 12 is 3 times 4. 3 is prime, 4 isn't, so then I can do 2 times 2. So I can say 120 is equal to 3 2's, 1 3, and 1 5. So when I type that in my calculator, I check to make sure that it all multiplies back to give me 120. For 44, I can do 4 times 11. 11's prime, but 4 is 2 times 2. So 44 is equal to 2 squared times 11. Or you could write it out 2 times 2 times 11. So when I type it in my calculator, 2 squared times 11 does give me 44. I know 78's an even number, so I can definitely divide it by 2. Goes in there 39 times. I know 39's not prime because I can add the digits 3 plus 9 and get 12, and 3 can go into 12. So if 3 can go into the digits added together, that means 3 can go into that number. So 3 goes into 39 13 times. Now 13 is prime. So I think it's 78 is equal to 2 times 3 times 13. And when I check it on my calculator, I know I've got it right. The only reason that I wouldn't be able to check it on my calculator, or I might think I'm right, is maybe I multiplied something that I didn't break down into prime numbers. Numbers 7 through 10, you have to find the greatest common factor of each pair of monomials. I really want you to be able to look at these and do them mentally. So I can look at this and say, okay, between 6p cubed and 2p, what do they have in common? Well, I look at the numbers. My greatest common factor can only be as big as my littlest number. So between 2 and 6, 2 is the smallest, so I know my GCF cannot be more than 2. I know 2 goes into 6, so I know between the numbers it's a 2. Between a p cubed and a p, there's 3 p's, there's 1 p. The most amount of p's they can have in common is 1, so the GCF is 2p. For number 8, what's the greatest common factor between 12 and 18? Well, the biggest it could be would be 12, but 12 doesn't go into 18. So then, what's the next biggest number that goes into 12? 6. Oh, 6 goes into 18, so I know it's 6. They have an x in common. This one has 3 x's, that has 4 x's, so the most of x's they have in common is 3. So notice I'm always picking the lowest exponent. Between negative 15 and 20, The biggest it could be would be 15, but that doesn't go into 20. So what can go into 15? Well, 5 can. 5 also goes into 20. They don't have any variables in common, and it wouldn't matter if you put positive 5 or you put negative 5. So you could have the sign different for your GCF. That doesn't matter. Between 3 and 4, there is no common factor between 3 and 4. So if nothing has a common factor, it's just going to be a 1, and there's no letters that are the same. Now, let's say you can't do these mentally. What's the process that I would use to come up with it? So if you can't do them mentally, you factor them out. So 6, if I go back to number 7, 6 is 2 times 3, and then I have 3 p's. Then I have a 2p. Well, what do they have in common? They have in common this 2, and they have in common that p. That's how you get 2 times p. If I was going to do the 8, number 8, 12 is 3 times 4, but 4 is 2 times 2. So I'd have 2 times 2 times 3, and then I have 3 x's. 18 is 2 times 9, but 9 is 3 times 3. And then I'd have 4 x's. So what do they have in common? They have in common this pair of 2's, they have in common a pair of 3's, and they have in common 3 x's. So what is 2 times 3 times x times x times x? Well, 2 times 3 is 6, and 3 x's can be written as 6x cubed. For number 9, negative 15 can be negative 3 times 5. 20 is 4 times 5, but 4 is 2 times 2, and then I have 4 s's. So then what do they have in common? They have in common that pair of 5's, and that was it. So that's how I know my GCF is 5. Now see, somebody else could have put the negative on the 5, and then they could have had a negative down here and a negative on the 2. So that's why the negative doesn't matter when you're doing GCF. So then on number 10, I would write 3 times A, and I would write 4 times B times B, or just 2 B's. So there's nothing in common, but you can always say it's 1 times 3, 1 times 4, and then they have a 1 in common. So there my GCF would equal a 1.